Okay, so up next is Lisa Cao. She's a product manager at Data Strato. She also helps or leads organization of a couple of meetups here in San Francisco. So you should definitely follow her to find out where and when they are and go to them because they're awesome. But yeah, I'll let you introduce yourself. Lisa.
Awesome. Am I good to remove this from the stand? Okay. Hey, everybody. Hopefully you're doing well. There have been some really incredible talks today, so I feel like I have to follow that up somewhat. But I'm really excited to be here with people who are really interested in open source as well. So I'm talking about REST catalogs today, specifically for Iceberg tables. But the open source is kind of a given because there's been so many open source catalogs that have released, but we'll talk about other catalogs too a little bit. A little bit about me. I am a product manager at Data Strato. So we are maintainers of an Apache project called Gravitino. And we were kind of like the first to do a REST catalog service for Iceberg. And so that's kind of how a lot of people found our project and found our company. And then eventually there were a lot more REST services that kind of came out for Iceberg tables as well. I'm also part of the Linux Foundation. So I'm part of several committees, including LFAI and Data, the Generative AI Commons, and OPIA, which is now part of the Intel project. I also am an ambassador for the Continuous Delivery Foundation and Google Women Tech Makers. And so I organize a lot of events and I love connecting people in groups. So if you're ever interested in enterprise AI, do talk to me about OPIA. We're building out our developer experience committee currently. So we're going to talk a little bit about Iceberg in terms of how the catalog works and how it interacts. And so the actual catalog implementation of Iceberg is it's a technical catalog or a meta store. It's not necessarily meant to be functional in the same way like a business dictionary would or a way another data catalog would. And it's really just meant to track tables and metadata and to act as a registry for these tables, right? It's meant to be your source of truth. And you really want to be able to have that be a secure backbone for your data infrastructure so that other tools can be able to work with it. And so you need the Iceberg library to actually be able to keep track of those tables by name, even though it's not necessarily a catalog that's used as a catalog for your entire company, but Iceberg still needs to manage it somehow internally. So the catalog itself is a collection of tables and it's grouped into these namespaces. And it's really important for the catalog to keep track of the current metadata and any changes to the metadata that occur, especially when you load a table. So this is kind of the structure of how it's implemented. And you can see that it points to different manifest lists, which then points to manifest files and then data files itself. So how this is actually implemented is pretty straightforward, but if you want to use it in a production case scenario, you really want to be able to have your catalogs be queryable by different engines, and you want it to always be up to date. And so let's say you have multiple catalogs like a JDBC catalog or Glue. You also want that to be interoperable with whatever Iceberg catalog that you have, instead of always just trying to rely on just one because different catalogs work with different sources. But you also want to be able to commit and have those changes persist and have ACID compliance. And then oftentimes you'll have multiple engines that are querying the same data as well. And so catalogs in Iceberg themselves are really about, you're initializing a catalog and then you configure it. But the actual catalog itself acts as an interface for different engines to query. And so you're going to execute your catalog operations within the catalog itself, and then you're going to pass on the set of properties when you query it or when you have an engine interact with it. So depending on which engine you're using, those actual properties will actually differ. But generally speaking, the Iceberg catalog is mostly just an interface. It's not necessarily a service. And we're going to get into what that means in a little bit. So catalogs are pretty useful just because generally you don't want to always be working with the data directly, but they're really meant to answer two questions, which is, where are my tables and how can I access them safely, especially when you're dealing with just so much data and you have so many different roles, you have different permissions, you want to implement access-based controls, and you also want to be able to track your Iceberg tables and the changes that they undergo and allow external tools to be able to interface with them. Iceberg is really a format, first and foremost, and we're going to get into how that vision has shaped the cataloging ecosystem. But generally speaking, you also want to enforce some sort of ACID compliance. And I think that, ACID compliance is something that will plague catalogs for a while and has shaped how we view catalogs in this modern day and what we're actually using them for. You also want to have your catalogs be able to move with your architecture as well. So regardless of whether or not you're working on a data mesh architecture, or you're building a data platform for the first time, or you're working with a lakehouse, you want your catalog to be able to move through these different changes that you have. So currently within the ecosystem, there's two different types of catalogs that we've seen. The first is service catalogs, and the second is file system catalogs. Mostly, we associate file system catalogs with something like Hadoop or Hive Metastore, where you're actually tracking the tables using a metadata file, and you're using the hard location of where that file lives, and it's pretty tightly coupled. This can be prone to more inconsistencies because this involves a lot of locking mechanisms, so you're locking and unlocking in order to make consistent changes to your metadata, and this can actually be really tough in production. You also have service-based catalogs, which can either be self or cloud managed, and they use some sort of external store to store where that metadata is, and then it maintains all the references there. And so then your locking mechanisms are kind of abstracted out in some sort of way. So the evolution of how these catalogs have kind of come about, and we'll talk a little bit more about these in detail. In terms of the actual history here is pretty straightforward. So at first, everybody was kind of using Hive Metastore because MapReduce was fairly big at the time. And oftentimes, if you were actually changing formats and you wanted to adopt Iceberg, you still had to work a lot with Hadoop clusters. And so Hive Metastore then was used to manage Iceberg tables as well. And this was pretty common. But Hive Metastore was not really meant to be used in this way. And you'll see that a lot of the times those locking mechanisms that come into place would actually get in the way of using Iceberg really efficiently. It's also pretty overkill. And so there were a lot of experiences in terms of just like how bad it was at scaling into production. You'll also see JDBC catalogs used a lot in terms of, relational stores. So you're abstracting your metadata out into these SQL tables. But there was also difficulties with ACID compliance, especially when you're using them to manage Iceberg tables, especially because different sort of storage systems and different JDBC connectors will have a lot of inconsistencies between them, right? They're implemented all a little bit differently. And so ACID still was a really tough thing to kind of nail down correctly. And so then in Iceberg 0.14, there was something called the Iceberg REST API specification. So REST catalogs had kind of become a little bit more popular, but this wasn't necessarily a service. It was a specification. So it was a document saying, okay, this is what we're implementing. If you follow these rules, it'll work. And then now in this day and age, as we've seen in the last couple of months, a lot of REST service catalogs have actually come out to make use of the specification. So Polaris is one of them, Apache Gravitino, which is kind of the one that Datastrato works on and maintains, Nessie from Dremio, and Unity from Databricks. And so you can kind of see that there's an evolution here from tightly coupled to a single technology to just kind of being very open and neutral. And this is kind of the theme of like why open source matters so much. And so we're going to introduce Rust now, which is, a very interesting, and I love that this is kind of the direction, but it matters a lot in terms of where we're seeing data architecture move towards. So actual catalog implementations, again, kind of an overview. We're seeing Rust now, so it's a server-side catalog that can be exposed then through a Rest API, but you still have to have a service that does that and a backend store. Hive Metastore, which we talked about as well, which is a file-based catalog, and then JDBC, which uses, mostly SQL tables to kind of track these changes. And then Nessie, which did something really interesting, which was kind of move into a Git-like direction to, track these transactions that occurred. But generally, we wanted something that was flexible, right? We wanted something that could be implemented using almost any backend if we wanted to. And generally, we know that had some sort of like backwards and forwards compatibility with different Iceberg runtimes. Oh, yeah. Should I stand over here? Is that better? Okay, thanks. And so this was something that was really important for us, and we also wanted something that was a little bit more ready to use out of the box. This still doesn't necessarily happen with the current implementation of Iceberg, but that's mostly because Iceberg is a format first and foremost, and the scale of that project is actually really important to the developers who are working on it. that they don't necessarily overblow it into something else. So you have a lot of different options instead. And so, yeah, how Gravitino works is kind of a little bit more interesting because instead of having a dedicated service, which currently in Apache Gravitino, we're abstracting out the REST catalog service of Iceberg, but generally speaking, it's more of a meta lake, which is why it's not necessarily seen as much. And so generally speaking, though, you kind of want your catalogs to be able to pool into each other as well. And so this could also be Unity that does this and tries to do this. It can also be Polaris, but Polaris is a little bit more tightly coupled to Iceberg itself instead of being like a general catalog aggregator. And then you also want to be able to have your different engines, query it, and then have those queries federate. So what kind of brought on this REST evolution and why is REST so important? You probably all likely know what REST is at this point. It's not so like this prescriptive like service itself, but it's more so the standard that people follow. And people can implement REST in a bunch of different ways. But generally speaking, you know, your client request is made and then it hits the API and then it gets handled by the server, which then has some sort of backend that it runs through. So generally this will return some sort of like standard data format like JSON, but also other different formats as well. So the reason why this has been so important in data architecture in particular is because data architecture is constantly evolving at this point. And generally we're introducing a lot of different languages like Java, Python, now Rust is becoming very popular. And so you kind of need a central place to manage all the metadata, but you don't necessarily want to have it be out of date in a few years or something like that. You want to be able to make sure that the jobs that you're running over these years have some sort of like stability to them. And so actually abstracting out a lot of those catalog processes into something else is really nice. And so you want to be able to make sure that, again, it's compatible with your Iceberg versioning, whether it's backwards or forwards. And so currently, like I said, Iceberg provides a open API specification that can be used, but it's not necessarily usable out of the box as it is. You actually need to have some sort of like third party, or you can build it yourself, a service that actually makes use of it. And so you can provide that REST service. So this implementation, again, is a server that needs to be able to handle the requests. You need to have some sort of store to be able to store the metadata in and I'll track all your changes. And then you'll be able to have something that's a little bit more usable in production. But you can also, one of the nice things is push it to another catalog, for instance, or utilize multiple catalogs if that's what you choose to do. So one of the advantages of REST that we have is that it requires fewer actual dependencies on the client side to be able to run these requests, which is really nice. And because it's really just HTTP, right? And it's pretty flexible because of this. It actually evolves quite well. REST is pretty standard these days, and it's pretty predictable, and it can be supported by many different services and technologies. It also supports multi-table transactions, which is something that Hive Metastore could not do. And it's also a little bit more cloud agnostic. And if you have a multi-cloud architecture, it can actually support that instead of being tightly coupled into one particular cloud ecosystem. There are some disadvantages, though, to using REST, and we'll kind of see this come a little bit more into play in the future. So generally, even though it requires fewer actual things to run, hold on, this is wrong. I'm going to speak over this part because I pasted the wrong part, and I am so sorry. But generally, you need a dedicated process to handle these calls. And it's a little bit more of an infrastructure load, right? And you need to be able to implement your own store to be able to handle the metadata there, especially in production. So it is more overhead, even though you get more customizability and you get more control over the end of it. And then generally speaking as well, you actually need to provide REST endpoints for the catalog to interact with. And you oftentimes will have to write your own if you're not using a managed service. A managed service was previously offered by Tabular, and so you can kind of go to third party for that, but generally speaking, depending on your architecture, you might have to write it yourself. And generally, the use cases, even though flexible, requires a little bit more overhead. No. So when choosing a catalog, you want to have some specific considerations, and this was kind of stuff that we saw previously in the past as well, which is whether or not you can write it for production and whether or not it'll deploy well in production, whether or not it requires an external system, whether or not you can host it, or if you have a managed service that you can go to. Depending on the compatibility and depending on how widely supported it is, like generally with other technologies, you will want to keep an eye on this as well, and whether or not it can do multi-table and multi-statement transactions, which I think is becoming more and more important, and whether or not it's cloud agnostic, which is, again, very important as well. So current examples of REST catalogs on the market. So Unity Catalog, which was recently open sourced by Databricks, as well as Polaris Catalog as well, is out. So these are pretty recent developments within the ecosystem. Nessie, which is backed by Dremio, but I think they're also undergoing the process of either integrating with Polaris or becoming a Apache project as well. So we're going to see a little bit more developments there. And Apache Gravitino, which is currently an incubating project. And kind of the big question here as well is, why is it all open source? So this is a really fun question that I really like, which is data catalogs were originally kind of meant as this idea of breaking down data silos. And as we noticed more technical silos between different formats, it became very important to address this. And we're noticing that now, that open is kind of the way to break down these silos and vendor locks. As well, we're noticing that different architectures have evolved to become more unstructured, and that different types of data need to be supported as part of this. And, you know, kind of going to the end point here of the vendor neutral position, catalogs were mostly controlled by specific vendors previously. And now that people can implement their own catalogs, especially technical catalogs, you're no longer just a user of somebody else's catalog. You're implementing and maintaining your own catalog. And I think that's a really big game changer in terms of how we view and approach data architecture. And so there's a lot of different open source strategies for different companies that are kind of coming into play. I won't go into all of them, but generally speaking, a data catalog, especially a technical data catalog, is a safe thing to open source because it allows other users or players in the game to be able to tack onto that. So yeah, thank you so much for this presentation. Okay. Are there any questions by any chance? Yeah. What catalog should you start with? Okay, full disclosure, I work for a company that creates one of these, so I have to say Apache Gravitino. But generally speaking, I think if you're going to choose a catalog, you should choose one. But if you're going to choose an open source catalog, you should know that they're pretty easy to migrate and implement at a small scale and at a POC level. So really, you know, look into what it is that you need supported, what engines you need to be able to have it interact with, what type of metadata and governance your organization needs, and what kind of pluggability and frameworks you have. I think that's really important. But generally speaking, like at least Gravitino is kind of a catalog that sits on top of other catalogs. So that's an easier migration. But other catalogs will be much more difficult. And it depends on the catalog itself. So say Polaris doesn't really make sense if you're not using Snowflake, to be honest. That just doesn't make sense. So you're going to have to do a little bit more of a deeper dive there and look at the features that you want as well. Hopefully that answers your question. Yeah. Yeah. Oh, I guess you can go first. Yeah.
More like high availability of like running the people or like way both thing on that. So the thing like the right path of like multiple and like clicking right at the same table, but it's stitching server side like economic.
Yeah.
Read by like I built read like read up the and you just feel like all those stickers because single plus scripts data back and
Yeah, no, I think that's a really big question. It's something that we've gotten asked a lot too. In terms of HA, I think that everybody's approaching different architectures, but it's very important. Oftentimes what you can do is deploy multiple instances. So Gravitino, you can deploy multiple instances of, so that if one instance goes down, you can have sort of HA architecture still in place. Although I think that can be improved. And I think that there's a lot more around it that can make it more production ready.
Like Lars and you go. That.
So I think that it varies because in terms of HA, I imagine that if you're using it under some sort of Snowflake service, there's a little bit more of a guarantee there versus a self-deployed option. The same thing with Unity, I'd imagine. So you might want to talk to whoever your support engineer is then. Yeah.
The backup wall, you're running that right, like the defined way. I am.
Yeah, it does integrate with cloud vendors IAM. So we create a layer on top of all of those architectures to be able to define roles that are compatible as you push down. But generally speaking, the fine-grained access control is something that, at least for us, we're still working on. And in terms of the other catalogs that you see, will depend on which framework that they're trying to plug into, right? So that hopefully that answers your question. But in terms of like row level and column level, that's something that we're still kind of working out. It's on the roadmap for the next release, though.
We assume that other governance features beyond ACL, like EDA and stuff like that, that's right. That's a talk to.
Yes. And I think it will be implemented in various different levels. I'm trying not to be about Gravitino. Depending on the actual catalog that you're using, it will be at various levels. But the nice thing about open source is that if you want to integrate with, say, open metadata, and you want to integrate with, say, open lineage, I think that would be really strong in terms of bringing the project to the production level that you need as those native features get fleshed out. But yes, that's definitely like the full governance spectrum is what we're looking at.
And would.
Yes. Yeah. We're very hard on the open source. So yeah. Any other questions? Oh, okay, cool. Thank you.